Good evening! Sleepy north side of Chicago, doing nerdy things for whoever's out there on the internet. Today is the first time I'll be streaming from the new workshop, which I wish I had a better way to show y'all, but it's pretty sweet. It's not that different in terms of its functionality from the old workshop. And by new workshop, I mean I'm in a new apartment, and I have a new office, and it's still very much, you might be able to tell from the boxes behind me, it's still very much in progress. But things are happening. It's very exciting here. You can see, I pan you this way. You can see computer desk there, storage shelves. The 3D printer still lives up above. And there's me. I don't think I can show you the shelving here. Yeah, you can just start to see the oscilloscopes and all the good stuff that's there. But there's me again. So tonight, I've been doing a little bit of work in the workshop recently. Most of the past couple weeks have been unpacking, and setting up our new place and setting up the kitchen and all this kind of good stuff. But I've squeezed in a little bit of time today and in the past couple of days to do a little bit of work on the tiny moving light project. And so tonight, I want to do just a little bit of work as far as adding zoom capabilities to the tiny moving light if I can. The tiny moving light, for those who maybe haven't seen it, I wonder if I have a good way of showing this off. One of these little guys. So, still don't have a name for these little things other than tiny moving light. As you can tell, it's about 5 inches tall. Got a pair of servo motors in it, and an emitter in the front there. Puts out about 800 lumens, 1,000 lumens, so like about as bright as a 75 watt birdie. And so far it's been fixed beam. I've been using these fixed beam elements from Carclo, who are well, this is what they do. They make tiny optics for your chip on board LED products. If I can get you to focus, if I do this. Yeah, so you can see 3 elements there, 3 individual lenses that goes with the 3 different emitters on the front of that moving. So what I thought I might play around with as like a next feature, in addition to, I think there's another revision of the PCB coming in. I've done some work on some like hanging hardware and some trussing, but I think a next like primary feature for the light itself is going to be zoom. Let me hang that back up on this little stand here. And full disclosure, I actually don't know if anything that I'm going to do tonight is going to work. I mean, I'm fairly confident that the electrical part of it will work. I don't know if the optical part of it will work. I'm not an optical engineer by any stretch. So we'll have a good time. We'll see what happens, and we'll see what happens, I suppose. Let me show you what I've got going on the workbench here, which I've sort of spent the better part of this afternoon setting up. If I do this, yeah, So let me take you through what we're looking at here. My little pointertronic. Let's see if this is in focus. Yeah, that's pretty good. There's nothing hidden under me over here. That's just the extension arm. So this here is a 3-up emitter. That's one of those same 1,000 watt emitters from Carclo, and that has this narrow spot lens in the front, which we're going to start with experimenting with. This whole setup here is a stepper motor arrangement that's hooked to an Arduino Pro Mini and this little control board. So, and then this is just a stepper motor that we're going to use in this sort of sliding platform. We're going to mount some lenses to this and use this as a way to sort of shift our lenses back and forth, and we'll see what that does to our optics. So just briefly before we get into that, I want to take a look at this stepper motor driver setup because it's kind of interesting. Let's see if I pull this whole thing forward. Sorry, motion. Yeah, there we go. Find a way to sort of level that out and tip that back this way. Something like that. All right, so what we're looking at here. So this is a stepper motor driver module that I had in the junk box. It's based around an L298N, which is this big power IC in there with a heatsink mounted on it. A bunch of diodes to alleviate any flyback current that might damage the chip. It has a power input for the driving voltage of the stepper motors in question. We'll look at how this is all wired up in a sec here. It's grounded, and then it also has a 5-volt regulator on board, which I'm using to directly power this Arduino, which is quite nice. And then you'll see it has 4 outputs here, and these 4 outputs are hooked in parallel with these little LEDs, which I just wired up in place just so it would be a little bit easier to see when a given output is on. And then down here, that's basically the control inputs of that device are wired into this Arduino Pro Mini, and then this is just a little control module that I built a while back for this sort of project with a rotary encoder and a couple of buttons. Just like a really easy way to breadboard some controls when you're working with something like this. So we turn it on. Which power supply are you on? You are on this power supply. There we go. Set that for about 9 volts, which is what this this stepper motor nominally is meant to run off of. Here, let me zoom out just a little bit. Sort of manual zoom, as it were, just tilting the camera back up. Okay, I'll get this reset. So the whole point of this setup is to give us control of this stepper motor. And to talk just briefly before we run it, quick look at how oops, that's my cheatingness, how an H-bridge driver for a stepper motor actually works. Right, so this configuration here that you're looking on the screen is called an H-bridge. You can build one out of discrete transistors. There's just 2 of them built into that stepper motor driver that we were looking at just a moment ago. And all it is, you can see, you have this motor represented here, this motor winding. And if we pass current, if we pass DC current through it in one direction, let's say you pass from 12 volts here to ground down here, the motor will spin one way. And if we pass 12 volts here down to ground down there, the motor will spin the other way. If we turn on either both the high voltage or both the low voltage side of things, right? So if I apply 12 volts here and I don't turn on either of these 2 transistors, we're in what this calls a break configuration, right? And similarly, if we ground both sides, we'll be in a break configuration. So there's no in that situation, there's no current flowing anywhere, but also we're still connected through in a solid circuit. So any rotation of this is going to try to generate a current through, and that's going to sort of resist that current breaking motion. If we were to turn off all 4 of these transistors, this thing would sort of freewheel, and that'll become important. We'll get back to that in just a second here. So like I said, so this is an H-bridge configuration for a single motor or motor winding. But in a stepper motor, you actually, well, this is not always true, but you often have 2 or more windings. This is a this is a drawing I found from Last Minute Engineers, which is quite good. So in a stepper motor, you might have these 2 different windings, A and B, and by which one is energized and which configuration, that's what allows you to have your steps of rotation as you sort of move your motor around in a circle. So because you have 2 different windings, you need 2 different H-bridges. Right, so that's what this drawing is showing. You have your A+ connection could be either tied here with this switch, or in our case, a transistor, to our positive voltage or to ground, or in the same with our A- winding here from could be set to positive or to ground. B could be tied B+ to positive and ground, B- to positive and ground. Of course, you would never want to say, let's look at this A+ winding here. You would never want to tie this FET closed to positive and this FET closed to ground, because you would just make a short circuit. And that's part of the nice thing about these H-bridge driver chips. You could build this out of transistors and control it directly, either with a microcontroller or with physical switches like this. But doing it with a driver chip, they're set up in such a way that you can never have a short circuit through them if everything's going okay. So that'll be kind of a useful thing. So to go back to our tabletop here. So let's see, there we go. Set up basically, as long as I'm holding this switch, this platform is going to, this stepper motor is going to move in one direction. If I hold the other button, we'll move in the opposite direction. And that's a really simple Arduino program, and we'll take a peek at that too. I swear I'm not just teasing, we will actually do some of these things. Let's see. How do I... Arduino. No? Arduino. There we go. Something squirrely going on there. So So this is really a very, very simple Arduino program. All we're doing, we define our steps per revolution of our stepper motor. That's easy enough. That was something I sort of derived empirically. I basically set it to do one step at a time and had it count steps until it got to a 360-degree rotation, and I got 400. Couple of input pins. Single step is a single step. This timeout function, we'll see in a second here why that's important. And then all we do is we in our primary loop, if our button for rotating the motor clockwise is depressed, right, is low, then we do a single step and we remember the time that it happened. Otherwise, if we're doing our counterclockwise button is pressed, we take a single step in the other direction and we remember what time it happens. And then this is that timeout function I mentioned just a moment ago. What I found was that when this was being held in a braking configuration, this is literally, I got this today from American Science and Service, the price tag on it. I don't know what it was originally meant for, but when it was in a braking configuration, right, when it was just held static, it got very, very hot. So what I did was add, something's not working with my Arduino switcher again, there we go. What I did was add this, this timeout function, right, which just says if millis, right, if the current time since the program has started minus the last time we saw a button get pressed is greater than our timeout function, which in my case is 250 milliseconds, we're just going to set all those digital pins to off, right? So we'll be in that freewheeling sort of configuration that we were seeing a moment ago. And you'll see that happen here when I run this. When I run this, you'll see all four of these will appear to light up dimly, and that's just because they're alternating on and off, in quick succession. When they stop, you'll see only two of them will ever be lit up at a given time, and then a quarter of a second later, they'll all turn off. So that'll be, alternating back and forth, high, low, high, low, high, low. They'll stay on for a second in that braking configuration, and then they'll turn off, and that's how I've programmed it. So let's make sure this thing still works. Yeah, look at that. And there's our off section. Let me do that again. You can see it's not a specific two that are on at the end of each rotational time. It's just sort of arbitrary wherever we ended up. Fun, right? So that has, any number of uses as we're examining things. But my thought is, this is obviously, this big fat stepper motor is about as big as the moving light itself. So I'm not proposing to use this stepper motor in the actual light. I am proposing to use this as a sort of a test bed to do some optics experiments. And then when we find sort of some promising combinations, we can look at going to a miniature servo motor for the actual sort of integration into the light. I found these adorable little stepper motors. Let me see if I can get the focus there. Yeah, look at how adorable that is. So these I got on AliExpress for like 80 cents a piece. Not a whole lot of specs, not a whole lot of operating voltages. The tiniest little pins. Look at that. They don't even tell you which pin is which. I may have to sort of guess, but I think I can make a fairly educated. This whole thing is, maybe a centimeter of travel. My thought is that if we were to attach a lightweight lens to one of these, it could move forward and backward by about an inch, and that would give us some variability in our beam. But before we go to the bother of integrating that, I really want to see what lens combinations might actually do something when we put them in front of our source. Cool. So let's bring our source back in here. And again, this is just, let's get a little closer here. Might cut off part of that driver circuitry, but you've seen that. Just a little bit higher. There we go. The beams of these things, I'll give you a nice camera view so we can see what's going on down here with the actual beam widths. But let's run this back to 0. This is going to be the challenge. This motor wants to run away on me, but I think I have a solution for that too. Okay, there's that. And this guy. So all I've done here to power this, I considered, we're coming a little unsoldered there. We'll touch that up real quick. I considered putting together another actual DMX driver, and ultimately for integration purposes I'm going to have to. But for tonight, I'm just going to run this whole thing off of my not my current controlled power supply, so I can tell it to put 500 milliamps through this chip, and that will just be 500 milliamps, and that's all there is to it. Um, I won't have to muck around with the variable sort of current adjustable buck supply that's in the actual LED circuit. Obviously, the big DC power supply is much larger than I would have in the real thing, but I think for the sake of experimentation tonight, this is just going to be a lot easier. So, real quick, I'm just going to, I've got a loose solder joint there. There we go. Yeah, that's come off right there. So, I'm just going to quickly resolder that. I'm going to use a little flux, which makes a huge difference when you're reworking solder joints, especially SMD type stuff. Because of course almost all solders, I guess maybe not almost all, most solders have a rosin core and have actual flux. But if you're reworking, of course, that flux has already boiled off long ago. So we'll take this, detach our power lead there. I've got my little tiny thin little tip on this from some work I was doing earlier, but it's going to make things a little bit challenging, but I think we'll be okay. All right, I think that'll be fine. Give that a second to cool. So, a few months ago, I treated myself to a nicer current limited power supply. For a long time, I've been using this Elenco analog one that I found at a Hamfest for about $15. And I treated myself to a nice $60 or $70 one from the internet. It's digital and it's fine. It's not, it's not fancy, it's not programmable, but it does have a digital voltage and current readout, which is kind of handy in a situation like this when I really would like to dial in exactly 500 milliamps, more or less. All right, so I'm just gonna stick my emitter back on this here, and all this is, let me show you up close. This is just a little tiny TO220 style heatsink, as we discovered in our last stream where we totally didn't burn ourselves. Let's see, focus. We totally didn't burn ourselves. This little LED chip doesn't actually need a whole lot of heat sinking to be just fine. I've been running the chips inside the PLA lights themselves at about 1 amp, and they've been fine with just a little tiny I think an original one was a Raspberry Pi style miniature heatsink, which has been fine, but just so I don't fry anything too early tonight. I got this on a little tiny heatsink of its own, and I'm gonna kind of use the pressure of these little clip leads to help sort of hold this against the heatsink. It's just stuck on there with a little bit of heatsink adhesive, and then we'll put the lens back on the front of that. Okay, so I've got my test rig, and I'm going to use some really high-tech science to help sort of keep this all in place. I have mounting putty, or what we used to call blue tack. I'm just going to use to stick this motor in place so that the little traveling bed moves instead of the motor sliding around all over the place. Alrighty. Just sort of smoosh that down there. Okay. Now hopefully I have to rethink how these wire leads are benched a little bit here. Tuck those under. And plug the optic back in there. Great. And now hopefully when I run this, here, let's get this whole thing back in view. There we go. Hopefully when I run this. Yeah, there we go. So now it's the platform moving instead of the motor pushing back on itself. Well, that works pretty well. All right, so let's run that back to 0. Well, let's give us a little bit of room to work with. So the question is, what kind of lensing, what kind of lens or diffusion is going to give us any kind of interesting magnification effect? Let's find out. So, like I said, I was at American Science and Surplus earlier today and bought, I wouldn't even say every lens that they had. There were a lot of options that I didn't swoop up, but I bought a handful of like inexpensive lensy type things for experimentation's sake. Starting with this 1 3/4 necklace magnifier. Ooh, shiny. Here, I think this is probably about time. So I think you all get the point of this, right? It's gonna slide forward and back, right? And we're gonna stick a lens on here, and that's gonna give us the ability to sort of see what happens when we move the lens forward and backward within our field. I am just gonna go ahead and, can I take this chain off? I can. In just a second here, I'm gonna move this camera angle around so that it can see both the device and the sort of beam of light that it's emitting out here, because I think that's going to be the interesting part of this experiment. So let's see here. There's not really going to be a good way to do this, but I think messing around with it's just a little, not a decent solution involved. Let's see if that's any good. Oh, upside down. But other than that, we can make that better. Right side up. Yeah, so now. So really what you want to do is slide over this way. Become a little more perpendicular. Yes, there we go. Excellent. So, right, so we've still got our emitter is just here behind these power leads, the servo motor, the stepper driver, and let's give you something to look at. Just going to use this corner clamping bracket, which is meant for assembling things that have right angles on them. Chris says, I'm here for frying LEDs. Yeah, we'll get there. I'm not saying it's not going to happen. Chris, I don't know how long you've been here. I just said I was hoping that this little heatsink was going to be all right for our purposes for tonight. I think it will be. I hope to disappoint you, Chris. I hope we don't fry anything. So this is going to be our sort of illuminated surface. Here, let me turn my power supply on. That's going to be the lighting source for these LEDs. I'll just turn the current up slowly. No? Current limited? There we go. Yeah, there we go. I think we might have to turn the exposure down to something constant so this light, so if I make it brighter, the exposure changes. Although maybe that's not a bad thing. Here, let's find. Just real quick, we'll set up the camera and make this constant. We'll just lower the exposure. Yeah, there we go. Lower that some, and then if I turn this on, that's pretty good. Yeah, I can still see what's going on, but now it's a little bit more clear. Yeah. So that's just naked with this this optic in front of it. Maybe I can turn that down even a little. So that's at 70 milliamps. This thing is like super punchy. Funny, you can see, you don't really see it in person, but you can see how spotty it is toward the center. That's partly also a camera artifact. So let's put it just there. So I suppose the first thing we'll do is just see what our various lenses do when we put them in front of the beam. We have our our like old lady magnifying device. Put that in there. That's interesting. Here, let me tip it a little bit. Yeah. So it's interesting. You can sort of see those like triple halations, like those triple halos around the outside. It's because there's 3 individual emitters on this. I think they're each being sort of deflected separately by the lens. It's only when I sort of bring this out. Ooh, that's kind of fun. Look how spotty that got. It's sort of 3 spots, really, but... Oh, yeah. Look at that. Well, if I made this light very long, I could make it very spotty, is what I'm learning. So close-up is not super different from just the naked optic. And here, well, so let's pick some arbitrary units. So let's see, this is going to be, I happen to have this on 2 gradiated surfaces. So we're about 7.5 inches from this surface. And naked, the beam itself is, let's say, between 3 and 4 inches wide. So 4 inches wide is our sort of stock beam width at 1 Jeff glass length, 7.5 inches, let's say. So if I introduce this lens, it's a little bit, just sort of at 1 inch away, it's a little bit more focused. Close up, it really doesn't do anything, sort of introduce those artifacts. And it's only when we get to like, maybe, it looks like 1 inch away, I sort of get this more spotty effect. So that's kind of an interesting zoom. I mean, that sort of halo is not super interesting to me. But if we could move from here to there, from sort of 0 to 1 inch, 1.5 inch maybe on this lens, I sort of get a more focused beam. That's kind of fun. Let's see if we can automate that. I'm going to use a little bit more of the oldie blue tack. Find a way to sort of stick this in place. Yeah. You stay. Yeah. So that's sort of stuck in place there now with a bit of blue tack. Hopefully that'll stay. But now, let's see if I reach over, can you still see? Yeah. Now when I run this stepper motor driver in, you can see it's all the way to 0. Here, let me move that just a little bit closer. Let's say that a 1/4 inch spacing is about our minimum. That would be sort of our wide flood. And then when we move the lens back out, at no particularly great speed. This is also sort of making some assumptions about like the speed that this stepper motor is capable of running at. I've told it to run at no more than 60 RPM, and that's sort of an arbitrary limitation. Like there's no reason that it couldn't actually run a little bit faster. Let me see if I run this even further down. Let me sort of get back to that 1.5 inch spacing, and now we're very spotty. So that's kind of cool. I wonder if it's worth just experimenting. I wonder how fast this thing can run. Let me real quick, here, let's see. You can follow along. Oh, right, the Arduino one is not working. Let me fix that real quick. So let's take a quick look at the code and we'll see how we're going to adjust the speed of that stepper motor there. Interesting. So over in the code here, that speed parameter is actually something you set when you set, you can set that as a function when you define your stepper motor. So I set it at 60 RPM. Let's put it at 120 RPM, and we will just come around here and plug in. I'm super curious to see. So I standardized on this Arduino Pro Mini form factor for my project a long time ago, but it's 2019 and IoT is still maybe the future, or maybe it's not. But oops, there we go. Yeah, there we go. Just don't try not to leave you upside down for too long. The Arduino Corporation has come out with a new IoT-friendly family of devices for Ethernet or like IoT, like sending data to the cloud, or Wi-Fi, or maybe Zigbee or something like that. Bluetooth for sure, and Bluetooth Low Energy, which is super popular. And it's a little tiny sort of trinkety-sized form factor, and I'm really curious to see what that's about. Because like one of the obvious thoughts is like once this mini moving light thing works, could it get its data? Could I just give it power and get this data over the network, right, or over the air? And so I'm if that form factor really is small enough, I think it'd be a super cool and easy way to like schlurp ACN or ARTANET off the air and have it respond wirelessly. Would be pretty cool. All right, so we just did an update on the Arduino with the code we were just looking at, 120 RPM. Let's see if this thing will actually move any faster. Ooh, it sure will. Hey, that worked quite well. Ooh, neat. Here, let's do one more code update. So that was 120 RPM. Let's take it to 180. I don't know. At some point we're gonna find the max where this thing will just sort of stall out. But yeah, look at that. Ooh, what happened there? Oh, I hit the I hit the end of my travel. So you can see as this moves back, that beam gets wider and wider and wider and wider. Well, that's pretty fun. I would call that pretty much a success. Yeah, that's really cool. Oh yeah, so when I sort of get to the end, well, actually, what I'm really doing is I'm hitting this piece of tape that I stuck on here to make it really easy to tell when this thing's turning. Maybe we'll take a second and take, well, at this probably as far as I can sort of reasonably go. And that gets our spacing to just about 2 inches. Although I suppose I could simulate it by sliding this backward. Oops. The light will have to come with it. So it's right about there, right about just over 2 inches where the beam from the optic itself is just about as wide as this actual lens. And this is an 1.75 inch lens, right? So the current, this optic, which sort of defines the size of the front of the unit, is 1 inch, and this is 1.75 inches. So it would be sort of a wider profile. And obviously I would need, additionally, in addition to the width of this, I would need the ability to like put some kind of motor next to it. And for something this chunky, I don't know that our little tiny adorable baby stepper motor is really gonna cut it. Like, this is our guy. Isn't he adorable? But I think he's not going to be strong enough. But that's okay. So I would call sort of test number 1 with the old lady magnifier a success. So let's take that off. And I have 4 other things to try. I bought 3 of these sort of jeweler's loupe magnifier things, again, straight from American Science and Surplus here in Chicago. I'm going to assume that everybody who's watching tonight has been to American Science and Surplus, or at least knows about them. I think that's probably a fair bet. If not, let me know, because we should talk. I would love to tell you all about it. All right, so let's get that stuck back on. So let's start with the 6 times magnifier. Yeah, there we go. So nothing fancy about it. It's a piece of plastic with a plastic lens and sort of a plastic front there. I wonder if this just comes off, because what I really want is just that lens. Ooh, yeah, so that snapped right off. And then are you glued? It might be glued in there. None of these, of course, are like the final be-all, end-all of what the actual lensing would be, but just sort of like a place to start as we try and understand what the different lensing will do. Yeah, I might make a little. There we go. Ooh, that's neat. That's a small little lens. That's maybe 1 inch across. Just a little bit of a convex lens. So we're going to do this starting with. We'll start with the same way we did with the sort of grandma loop, which is I'm just going to sort of hold it in front of our test rig here. Let's get that pointed up a little bit so we can see what it's doing. And we'll see what it does. So if I start this at 0, again, not a ton of change there. And then if I bring it out, again, we sort of see that triple ring because we have 3 separate emitters. Yeah. And sort of, by the time we get to that where the maximum extent of the granny loop, You can see a lot of this sort of additional bleed around the side. And we're really getting to, look at that. You can see those 3 little points of light are in the same triangle that the actual emitters on the LEDs are here for. Wow. That's kind of neat. I wonder if some of these, if they were frosted, if they do anything additional. Like if they were just a light frost over it, if it would help sort of blend that edge a little bit. Yeah, so that's kind of fun here. Let's just for gets and shiggles. Let's say before we automate it, I'm going to do this now, sort of convex side toward the lens and see what happens. Again, not a lot of action at 0. Now we move it forward. Essentially the same. Essentially the same. Yeah, down to that sort of that 3-way point right there. That's kind of interesting. Let's just so we can look at it at the same time. We'll stick that back to our high-tech science putty and sort of get this, especially with this little tiny lens. I'm trying to try and get this emitter pointed right, sort of down the barrel of the lens itself, just so it stands as good a chance as possible of looking decent. All right, so with that in place, come over here. We'll run that back in. Yep. So that's 0 again. And now let's run it forward. So we run it forward, forward and forward and forward. So the parts that are intercepted by the lens obviously are, the most focused, but the total amount of light that's being captured by this lens is not super interesting. But that's all right. It's kind of an interesting experiment. So that'll be our ×6 lens. I'm going to set this aside in the ×6 box, so I hopefully don't get these two mixed up. And we'll try the 10 times magnifier. I would sort of suspect that we're going to have similar and stronger results with this one, right? So again, cheapy piece of plastic, cheap plastic lens, just a stronger magnification. So let's see if we get lucky. That last one just sort of fell apart. Ooh, well that came apart. That's exciting. This ring come off? Do I need tools? I have tools. Let's see. Oh, this one has 2 lenses. Oh, interesting. This one has a rear lens and a front lens. Oh, which I've kind of... Or... Oh. Did this other one have? No, this one was not a 2-lens system. The original one, so that 5x one was a single lens. This one has 2 lenses. And the second one was... Or is it just a cap? I can't tell. So I snapped off this ring, right, that... form the back of this here. I can't tell. I think that's a second lens. Well, regardless, let's try messing around. Get this out of the way. Try messing around with this as a whole optical unit. The lenses on the LED matter, says Chris. Probably, right? Oh, here, let me show you. Let me slip the optic on the LED off and show you the sort of native angle of this thing. Right? It's hugely wide. I turn up the current a little bit so you can see it. Yeah, it's a big blaster. Some Source Force have 2 lenses, says Chris. Yeah, it's true. It's true. Like I say, I'm not an optical expert by any stretch. So like I figure we'll sort of do the 1 lens combinations and then we'll see. Like I'd love to get clever about like the 2 lens combinations, and that like the fact that I'm pretty sure like that is the part of, you can see where that rear ring sort of snapped off. But I think that's a secondary lens there. My thought with leaving the narrow spot optic on to start was that we might like stand a chance of sort of having a narrow spot and then widening it with an optic, because all of these, let's think about this. This is a magnifying lens, so all of these are going to be a diverging optic. They're going to make a thing that's nearby look bigger. So I think these are going to be best at providing a wider beam than natively exists, but I'm not entirely sure. Yeah, well, I'll try anything. So let's take our 10 times magnifier here, and we'll just slip it in front of our beam and see what happens. Real close. Ooh, yeah. Here, let me get even a little closer, because all the interesting stuff is happening over here. Yeah. So we're just gonna slip that 10 times beam, and already you can sort of see that three lobed of those emitters. I guess the only reason that this looks halfway decent is that, like, in terms of the actual lens distance, this is far enough away that those three different lobes are blending. And then when you apply any kind of magnification to them, you get that sort of trilobe thing, which is kind of fun. So let's see. I just manually sort of move that back and forth. Yeah, like right there. We bring them into focus. And then we sort of beyond the beam from that end. That's fun. I mean, we could, like, in terms of like multi-lens solutions, like this is somewhat, so that's like 3/4 of an inch away from the front. This is like significantly, well, I think significantly sharper and more focused, sort of capturing all the light and bringing it down to these three lobes, and maybe putting another lens in front of that would be interesting. I don't know. Here, let's squish this into our science putty. And I really did put the controls for this at a very awkward place. Ooh, I'm gonna hit my own motor. There we go. That's as close as that'll go. So then I'm gonna have to get this guy right up in there. Yeah, I'll get that right up in there. Can you see any of that? No, probably not. There we go. So, what's Chris say? No experience. Think about all the light fixtures taken apart. Haven't taken apart any LED stage lights. Yeah. So the emitter technology in a color force, and again, this is like what I don't understand is, so if you have a source for color source fixture, right, and you take the lens tube off the front, which for anything but a 36-degree is a single lens, right, or a 19, a 26, a 50, a 70, a 90, or a single lens. If you take that out, what you're looking at is a rainbow constellation of many diodes, which must all be pointed at the focal point, I guess, or like whatever optic is in front of them is all pointed at the gate of the light is the only thing I can think. That's sort of like where my knowledge of LED fixture optics ends. So let's see. Let me get this up a little. Just try and get this centered in the lens here. There we go. So that's more or less centered. You have that sort of trilobe action, and then as I move that away, yeah, not quite lined up. We're seeing a little bit more spillover than when I was doing this by hand, but I think that's mostly because I just haven't lined up the LED in the lens as well as I could. You know, this does make a little bit of sense with the sort of the granny lens being our sort of sharpest focus at this point. Sort of following the laws of entendu, which is an amazing word. And like I say, not just a guy who Googles things, not an optics expert, but conservation of entendu basically says that the product of your apparent, your beam width and your apparent source size, right? It's the product of how big your source looks times the apparent angle that it covers. So that quantity is called entendu, that product of two things. And it cannot decrease without loss, right? There is no way to take a light that's coming out of a hole that is that big and make it come out of a hole that's that big and have the same beam width, without having some loss, right? So and this is why whenever you see like a Sharpie beam or what other beam fixtures did we just strike? Like the Ayrton Magic Dots, which are like a super narrow beam fixture, all have a relatively wide aperture, and that's just because their source, right, is an LED chip of some kind. Turn I'm going to try not to crack. Oops. Trying to keep an eye on things and make sure the stream isn't falling apart too badly. My streaming software thinks that my bitrate is all over the place, so if you notice something squirrely going on, let me know and we'll see what we can do about it. Let's see if I can just snap this off again. I'm not sure I can. I'm not sure I need to. I guess, well, let's do this first, and then, here. But while it's still fresh in our minds, I'll take the 10 times magnifier and just put it backward. See if it does the same thing. I think it will. Yeah, very similar. Okay, so order probably doesn't matter too much, because, again, we're only looking at 2 lenses. Like, I fully imagine that if you have, like, a 10 lens system, like a fancy moving light like a Ghibli has, then it probably does make a difference, but for our purposes, I think it'll be all right. All right, so let's roll this out of the way. And we'll try our 15 times magnifier and see what happens. Whoa! So that's, we were just talking about color source spot when you take the lens tube off, what it looks like. It looks a lot like that. You get these super sharp images of the emitters. Well, that's not super great. All right, what if I reverse that one? Yeah, same thing. Well, that's not, I mean, it's kind of interesting. It's just not what we want. And then, yeah, that's not particularly useful at all. Oh, that's kind of fun. Look how sharp that gets. That's super cool. Stream quality is jumping around, not sure which end it's on. Yeah, Chris, it could be me. My computer went bing bing a couple times and my bitrate dropped and now it thinks it's back. So I don't really know what that's about, but I guess we'll find out. All right, so I don't think this one is actually worth putting on the stand at all. Like, that just doesn't look like anything. All right, so that was the 15 times. So that was fine. And then, let's see. I like it. American Science and Surplus is an incredible place. I just sort of grabbed this little guy, who is a MasterTech flashlight. Uses 2 UM3 batteries, not included. Does anyone know what a UM3 battery is? What about the LED lens for that last one? Ooh, I like the way you think, Chris. Yes, I've got my hands full of this. This is nothing. This is a piece of clear glass. And a reflector. All right, well, that's why it was 50 cents. Yeah, let's try this last one without the LED lensing. So let me turn the current down just a little here. There we go. I'm going to take the Carclo optic off. In fact, I'm going to shut this off for just 1 sec. It'll be a little dark here. I'm just going to... Got these leads coming off the front of the diode that are kind of getting in my way. Yeah, all right, let's turn that back on. It's going to come on bright. And then we'll dim it back down. There we go. Our test stand. Maglite lens? I couldn't find, well, at least when I was shopping around today, like all of the like Maglite lenses were like the 3/4 inch ones, and I just didn't think I'd be able to sort of get enough capture area around this for it to be interesting. I do have an old, what would be cool is like a bulky, like 8D cell style Maglite lens. Do those have lenses? Do those are they just I guess the LED ones must, right? Like the old incandescent ones, I'm pretty sure or the halogen ones were just a little tiny emitter and a reflector and a clear piece of glass. But the LED ones must have a lens. Let's see. I mean, the Dream is 3D printed lens, but those are just words. So let's see what happens when we put the 15 times optic in front here. Whoa! Check that out. That's cool. So this is like right up against the emitters. I get sort of 3 circles, and I move it forward here, and I get images of the little actual, emitters themselves. That's fun. I mean, that's super cool as an effects light. if nothing else. Make a a little party fixture. Right, turn it up to ludicrous speed. Well, half an amp. Be a fun beamy fixture. Like the world's tiniest moonflower. Getting a 3D print lens clear. Chris, I don't see what the problem could possibly be. I think it's foolproof. I mean, you could do like I don't know. It'd be fine. Let's see if we go the other way. Same idea. Yeah. Look at that. That's fun. I mean, not quite what I'm looking for, but it is interesting. I think the native emission angle on these is like on these diodes from Cree is something like 120 degrees ish. Like they're omnidirectional emitters, basically. So like you really, unless you have an optic right up on them, that's eliminating that beam a little bit. You just get like by the time my lens is here, you can see how much blowback I have all over the sort of the screen there. But neat. So that's sort of what's and it would take a second, but I do have, so this is the 3-up style of these emitters, which is like 3 diodes on a chip. I do have the single emitter version as well. It's a third the brightness, but it might solve some of these. It would certainly alleviate some of these tri-lobed issues that we have here. It's kind of interesting. Well, what do you think? I think the winner was Granny Lens. In terms of, let me define our terms. I think if we're looking for a wash moving light fixture that zooms for some reasonable amount of zoom, I think the large lens of the Granny Lens is more potent than the 6, the 10, the 15 degree sort of magnification lenses. Let me remind myself what that 6 looked like. Did you go? Oh yeah, the 6 was the one we could get all the way out. The 6 was this little tiny one. Yeah, that's adorable. Yeah, so I think that, I mean, if you just consider the beam center, let me get that back on axis there. This is actually not, I think, a bad solution. It's just, of course, because the lens size is smaller, by the time you get an equivalent distance away, you have a lot of lost light around the outside here. But that's okay. Maybe I turn this down just a little bit. Are you seeing, what is that? Oh, you're getting blow by. Yeah, there we go. Yeah, so I think, this is sort of the size of lens I was hoping would be ideal, just because, it's about an inch in diameter, which is about the same as the actual optic that exists. Does the 15 work better when your throw distance is more than 12 inches, says Chris. Interesting. Certainly possible. Figure out how to try that in a way that we can see. So if I could throw onto this wall here, the trick is going to be if I unplug this laptop or unplug any of the things from it, all of this is going to fall apart a little bit. What's the goal of the light, says Chris? Shorter throw for like model boxes? I don't really know. So I think there might actually be sort of 2 cross purposes, right? One would be for model box shots, right? In which case or model boxes, or like, I mount one like, just above my head here and it lights my desk, and we're talking like, 6-inch throws. Like 6-foot throws. Model boxes would be like a 12-inch throw. The other thing is sort of like with the brightness range that we're approaching, using them as little like scenic installed accent lights, right? Like basically a movable birdie. In which case, probably variable zoom is less critical, but it's just nice. Imagine you thinking of like a show that we did a couple years ago where we had like 6 little birdies mounted up underneath this balcony, and they highlighted the actors as they came through this doorway out under the balcony, right? If you would have lights that not only did that, but were small and, heat efficient and could move, and could potentially move and zoom, be kind of a neat feature. Even if you had to have like a remote sort of power injector relatively nearby. I want to get to sort of the new developments in power and data distribution at some point tonight too, because they're kind of fun. Let's see, what's the oh yeah. So, but I'm that all said, I'm totally game on this sort of optics experimentation night to try a longer throw. So let's see if I didn't really plan for this setup. Let me take this away and we'll see. Don't want this computer to go to sleep. Yes, you can see that on the wall there. Maybe if I have the room here, I'm gonna mute myself for just a second here, and well, maybe I don't need to. I'm just gonna turn off a little light on this wall. Yeah, it's a little better. I could probably get away with this flaring from here. Yes, and then we'll move this over. The the streaming setup in the new place is sort of the same as it was in the old place, and then I'm just kind of making it up, sort of Calvin Ball style. What I don't have is a whatever the technology is that would allow me to do things like this and just sort of place the camera wherever I want to and roll with it. That's not bad. As long as this doesn't go to sleep. Oh, there we go. Oh, you know what I also did grab? Just to get this up over the laptop here. Yes, there we go. Okay, so that's not awful. You can sort of see that. Maybe I'll just tilt this up just a little bit more using my tilty stick. And sort of tilt the whole apparatus. Oops. Tilt the whole apparatus. I really enjoy doing this live because it's the same kind of like bodging that I would do if it was just me, but now I get to share it with all y'all. Oh, Chris, life from making it up. Yeah, it's totally true. Okay. So this is our 6x magnifier lens again. Here, and I actually keep our original screen card handy here. Right, so that was what it originally looked like. And this is our quote unquote narrow spot optic. We can get that a little bigger. Yeah, no lens. This is lens at 0, and then just moving it forward. We bring those dots back into focus. So it seems like there is a range for any of these lenses where, like, I mean, I guess that's the focal range of these magnifiers, right? That's what that focal range means. Brings that source right into focus and then past that. Interesting. You know, it's another factor in all of this, as long as we're making up how optics work, is, you know, all of the emitters on this die are all coplanar, right? They're all shooting perfectly parallel to each other, and this optic is also sort of emitting, you know, in parallel, sort of coplanarly. It's not like they're converging on a point. I had a converging lens. There were a couple at American Science and Surplus, but they were tiny, like tinier than a single diode. Oh, I guess I haven't done the single emitter version of this with that. Sort of get these like to converge to a point and then diverge again. Kind of interesting. All right, let's get that 15 times out here and see what happens. That's our 6 times. That's our 15 times, right? So again, so this is, let's see, we can see a little better. You can see that's where I store the moving lights for now, and because I've hung them jauntily. Falling over a little bit. Oops. This guy's falling over. All right, so there's, again, so that's just naked. Um, and we'll take our 15 times optic there. Ooh, that's kind of nice. And we'll just slip it right in front. Wow! Wowie zowie. So our three big, so this one has a very short focal range, then, is I guess what that means, right? Which I guess makes sense. It's a 15 times magnifier. All right, I'm about half an inch, maybe a quarter of an inch from the emitter, and I'm getting that really sharp focus. As I move away, yeah, not a whole lot smaller. It's curious when I am wondering if I need a converging lens, you know, and I don't know. I would need to sort of source that. Although I'm sure, you know, for exactly this kind of application, there is something. This is just a reflector from that shitty flashlight. So, just for interest's sake. Yeah. I don't know. It makes me think, you know, when you see, like, when you mentioned a Maglite lens earlier, Chris, right? Especially those ones where you slide the front sort of in and out. I'll do it. When you slide that front in and out, and it like goes from a wide beam to a very like sort of sharp, usually a square. It feels like it's sliding from like in, you know, within the focal range, slides out to the focal range, so you just see like the square shape of the emitter diodes, and that's like its sharpest beam, right? Because often you see the actual square emitter as part of that. Oh, interesting. Let's put our, now that we've got our sort of long throw set up here, let me throw our granny lens back on just for one more visit. It's a little smudgely because I've just been very casual about it. Yeah. Oh, interesting. So that's actually closer to that focal range now. I'll tell you what, I'm going to take a hot second and peel back a little of the gaff tape here, because you all get the idea. And that's going to give me like another inch of travel, which might be interesting. Yes, So if I run, let's see, if I put my arm there, you can still see things. Run this in. You flickering. Oh, my constant current power supply is just a little bit unstable down at this low voltage. All right, so that's as close as can be. That's about the same as no lens. Let me get my shadow out of here. That's those same 3 rings moving in. If we move it even further away, yeah, I just start to overshoot the lens. So, you know, if I do wonder, like, if we had a little bit of frost. I think all of my frost is still in a box, probably not even in this room. But I have a little visqueen here. That's a part of my 3D printer wrap that I haven't reinstalled yet. That might be kind of interesting. I'm curious, like, if this was just a little bit frosted, so you couldn't see the individual lobes. Yeah, those 3 diodes not converging is kind of a bummer. I mean, we could take a second and try this with a single diode version. I had like 98 of those. I bought them, a bunch of them on clearance from LED Supply when they were on sale. It's just, they're just not sort of bright enough to be realistic. Like, whereas this is, you know, I'm gonna run this up to an amp. And remember, this is super low exposure, right? On the camera here, but that is super punchy. Let's see. What do I have that would stand in for frost? I could take 20 seconds and go get some frost. Maybe that's what I'll do. All right, 20-second break. Run to the other room to get some frost. I do this, we'll be right back. And we're back. Hello, I'm back with Frost. So to my chagrin, the only frost I could find is some of this stuff, which is pretty heavy. It's not like an R103, like super duper heavy, but it's not like the 132 that I was hoping for. But that's okay. In my recent move, I purged a lot of my theater stuff that I was hanging on to from freelance days, or donated it to a theater nearby. But apparently I kept just a little bit of this weird, like, super heavy frost. So I guess, let's see if this helps at all. So I'll put this like right in front of the granny lens. It's so heavy it's making it look like it's doing nothing. If I put this in front of this lens, oh, that's kind of interesting. So this is between the emitter and the granny lens. Yeah, interesting. So what if doubling it is probably too much for between lenses. Yeah, I'm just getting so much reflection. You can probably see back off of this frost that I'm losing a considerable amount of output, I feel like. Turn this up just a little bit in terms of current. Yeah, let's keep that at a single. That's going to be the thing about, you know, anything I put in front of here to diffuse it is just going to lead to loss. It's a shame. It's funny, you can see, so like this is right up against the emitter, this is right up against the lens. You know, that in itself is not a bad zoom. Again, except for that, like, the diodes are all together problem. Let's see if I take the granny lens away. Oops. Come on, granny lens, get out of there. So that's native beam width. Yeah, huh. So, I mean, I could just do a diffusion flag, right? You know, that would sort of eat into the, sort of make the width of the fixture itself sort of necessity quite a bit wider. But that's all right. Let's put our granny lens back. if I ended up using this granny lens in production, would you say I'd have to pay attention to all the granular details? I would say that. So if I run this all the way back in and drop the mini color scroller with frost, it would be adorable. Somebody gave me the idea a couple weeks ago, Chris, for a mini IQ for like an IQ for a Source 4 Mini, which would be super adorable. And also, I think not terribly hard, given that I already have a miniature pan and tilt solution. I don't know what you'd use it for, but honestly, if you had to have a tiny source that moved, miniature IQ on a commercial fixture is probably more reliable than miniature moving light that moves its whole head. Frost flag is kind of interesting. So let's run this back out. It's funny, you can tell just by looking at the diodes on the wall here whether the lens and the emitter are aligned. Because when they are, you get that super sharp, super pretty, let me turn this down just a little bit, image of those three diodes, and when they're not aligned, you get fuzz. So we were saying, I mean, it could just be a light that, it could be a static lens at that distance that moves this frost flag back and forth. I mean, you do get that like really strong sort of triple beam there. Let me move this out just a little bit further. That's too close. But if it was just a moving frost flag, I bet we could make that up. I think I could position this granny lens and the emitter in such a way that we could do a moving frost flag with this servo motor. So that was granny lens about here. Let's move this whole thing over a little bit. I'm clipping the laptop a little bit here, but I think we'll get the point. So let us figuring I can sort of reuse this servo platform off to the side here. This and a little bit of tape to sort of simulate this moving frost flag idea and see if that gets us anywhere that the moving lenses didn't. Oops. Let's see. Oops. Just tear off sort of an experimental process tonight. Ooh, it's a little floppy. Maybe I get this to sit a little higher and trim it down. When I say I'm going to do these streams, I try and think through like the various directions that like things could go in, just to like, like, oh, maybe we look at this, maybe we look at that, and just try and think like, what do I have at hand that I could look at, especially when it's like this kind of night when it's really just like experimentation. And usually it seems what happens is like things go in an entirely different direction, and that's kind of cool. I need a little like reinforcement flap of some kind. Just maybe a little crimp. That's it, all right. Oh yeah, so I just tape this frost to itself here. It's a pretty, I'll turn this off a sec so you can see. It's a pretty janky setup with the tape and the frost and the stepper motor. But it's working. I'll turn this back on. Go. Okay. And we'll tilt this back so you can see things. Is this a flare from something? What is that? Oh, that's the light shining through the lens. Yeah, So now it's interesting, getting the frost really square to the lens makes a difference. So that's our close focus there. Coming back out to sort of our far focus there. Our sort of widest beam. But, so it's kind of interesting, but this is like, you can see even on camera how much this frost is catching. Like, I think it's apparent even on camera that, like, just looking at that white wall, the relative intensity of these two, with and without this frost flag is pretty significant. So I think we're probably in the world of, I don't know, we'd probably need a less lossy, frosty solution. But a cool thing to try. Let's put our granny lens back up on our pedestal. There we go. That's that sharp beam that we know and love. Move the whole sheboygan this way. I mean, even from sort of there, we're not terribly lined up anymore. I think the other thing that I'm learning from this experimentation is that, like, the adding optical elements that aren't sort of pre-made lenses to existing LEDs means that the precision with which all of this would need to be placed increases significantly, right? Like, there's a fair amount about the current light that's very forgiving, in the sense that, the optical element is what it is, and it just sits within the body. And so if it's, if there's some part of it that is off by, a couple of degrees, who's ever going to know? Who's ever going to see the light is the light? But with this, now we have two optical elements, and they're moving in relation to each other. And that makes everything just that much more critical. Ooh. I ran off the end of my stepper motor sort of ball screw there. So I think, like, that sort of is as close as one could plausibly be. I don't think you can get any less frosty than that and have a usable light. Even that is an awkward beam shape for sure. But, and then this becomes more and more plausible as we go out. I guess the other option, so one other option would be to use a single emitter system, right, and just overdrive the crap out of it, right? Run it at like 2 amps, and see what happens. Chris, you did ask for burning LEDs at one point. If you're still interested, I feel like Now is the time, if any time is the time. Yeah, let's do it. Let's do the same setup. We'll do it with a single emitter system, and we'll use that same lens and see if we can get a nice zoom out of it. Real quick, let me get. Just gonna increase my exposure back up on this now that we're not sitting in the dark. Going to take you away from that camera view while I move the camera, just to be kind. Something like that. There we go. And then this needs to be flipped 180 or I'll lose my mind. There we go. Yep. All right. Power supply is off. Power supply is off. Arduino is unplugged. All the power to this thing is off. All right. Let's just move the whole kit and caboodle out of the way for a sec. We'll do a stream about soldering for just a couple minutes, and then we'll bring it back and see what we've learned. So, ooh, I guess we'll need a different, if we're going to play with an optic, we'll need a different optic. Although I do have these fun single emitter optics. Yeah, look at that. That's a fun one. That's going to be a real narrow beam. Oh yeah, and then this, I think, is my big bag of fun. Yes. So these were like on some kind of clearance or remainder from LED Supply. It was a bag of, 100-ish for $10. And I mean, how do you pass that up? Let's see. I'm gonna need a heat sink, a proper heat sink as well for this one. Maybe not too proper though. Do that guy. I don't think I mentioned yet, so we had Six, the musical, sitting at our space for the past few 8 weeks or something like that. And while it was there, so that plot had some Sharpie washes and some Sharpie beams and a bunch of Ayrton Magic Dots, which are these little adorable, like 4-inch ball head fixtures with continuous pan and continuous tilt. And they make like a 2-degree beam, and they're RGBW, and they're adorable. And they're only like a couple grand list. So you put 27 together, and they do, beams and dances and things, and it was all kinds of fun. So at one point, I took one apart just to see what was inside of it. And it had, all of the part numbers were Chinesium, right? So a little bit hard to decipher. But with a bunch of Googling after the fact, they were using a very similar sort of buck converter power architecture that I had settled on, which was super encouraging. And it was 4 RGBW emitters underneath a giant lens, and there were 4 of these buck converter power drivers sitting on a big fat 1/8-inch steel PCB underneath it, presumably for heat sinking the LEDs. And then there was a heat pipe coming off the bottom of that with a fan. But it was super cool to see that this architecture choice that I just sort of stumbled upon is in this real world fixture. That was super cool. And it makes sense, right? Because the whole point of it is that you're not wasting, you have a, presumably they're running it at a reasonably low voltage. So they're not wasting a lot of heat in conversion anyway. But I don't know, it's just neat. Oh yeah, that's gonna be really fun. Alrighty, so this is when we look it up later, this is a 7040 Lux Drive Endor. Just tin up our wires here. Let's let's see, we'll do opposite sides. I guess we'll do adjacent. And then we'll just take the power leads up and over the top. Ooh, yeah. I really should have switched out for that chisel tip. This little bitty conical tip's going to have a little bit of a hard time getting these pads hot enough to really work with. That'll be all right. If this was going into a light right away, I'd probably need to sort of figure out a way to route the wires around the PCB in a way that doesn't get in the way of the lens. But that's all right. It's experimentation time. Alrighty. So there's that here. Before we get too much further, let's grab our power supply leads here. Shove soldering iron out of the way. And we'll just hook this puppy up and remind us what color temperature this thing was. Turn the current all the way down. I'll turn it up slowly. There we go. I don't know, sort of a... Ugh. I mean, the CRI is kind of craptastic. That's like... Yeah, that's pretty green. I mean, I would say it's like a shitty warm white. Can I say a bad warm white? But punchy. Here, I just point this at a wall. Ooh, but upside down. So just for a quick comparison before we start putting other optics in front of it, here I'll run this at. Might be a little overexposed. I will turn some light off. So this is sort of the native beam spread of this little tiny light, and then a little tiny sort of star LED, and then with its optic, hey, look at that. That's already super spotty. That's pretty fun. I mean, honestly, ooh, seeing dots. Like, is that perceptually? I guess it is dimmer. It's as bright as a single spot was before, which makes sense. Needs a top hat, yeah. The nice thing about like the actual lights themselves, which you can see hanging on the wall, sort of there and there, the optic is inset into the fixture like a 1/4 of an inch, and that sort of helps a little bit with flare. All right, let's turn this off. Let's bring our... I think I'm gonna have to uninvert here. Right. Uninvert. There we go. Get that all nice and square. Oh, she actually should take us back to. Here, look at my face again. While I move the camera, so you don't have to look at the roller coaster ride that is moving this camera around the room. Okay, let's see if that's better. Oops, but also inverted. There we go. Okay. Get you a little bit lower so you can see more of what's going on. There we go. Time for a third camera or a camera person. You know, I just got a second camera, and now all I want is a third camera. But I guess that's always the way. Cameras were on sale this week at Micro Center, and I didn't buy one. I did very well. All right, so I got my heatsink, sort of a chunkier boy here to play with. I'll find a way to just sort of stick that just there. Guess we'll take this is off, right? Yeah. What I might do, this heatsink, again, just like a junk heatsink from a Hamfest, I'm just gonna thread our power and ground wires sort of right through it. And then just kind of curl over. So not, not perfectly centered, but I think this is going to be plenty of heatsink for what we are going to be doing with it tonight. At least, from what we learned, was it last time we streamed, like a couple months ago? That we burned all the things. I think it was a couple months ago. I think that was the last time this happened. You don't need that much heatsink to prevent things that are pretty beefy already from catching on fire. Hey, that worked out pretty well. Those heatsinks did get hot and burny, as you may recall. But ultimately everything survived and did not catch fire, which was a good feature. Let's bring this all a little bit closer. Nothing to look it up there yet. So just trying to get this heatsink into position, bend all the wires so that things want to stay. You know what I have, come to think of it? I have Build-Tac. Okay, so I'm going to just start by putting this optic on. If it'll stay. And if it won't, I have more Build-Tac. Why are you not staying? Yeah, it's time for more tack. I wonder if Build-Tac burns or melts. That's fine, right? I'm just gonna wrap the whole thing in Build-Tac there. That seems fine. It is staying, so that's good. All right, squish that in there. Squish that in there. Why are you not staying? The 3-up optics sort of clip in to the individual LEDs, and these 1-up, these single emitter LEDs don't do that, and that's kind of a shame. Well, shall we give it a try? Let's tip this back up so you can see the wall, which has become our test subject. Here we go. Probably melts like ice cream. Yeah. I mean, we can find out. We have the technology. All right, let's turn the stepper motor power supply back on there. Ooh, I need to turn down the exposure on this shot again, I bet. I don't think there's a way to do that programmatically. Like to like have a hotkey that would do that. Connect the Arduino. I actually don't have to connect the Arduino. So one of the neat things about this stepper motor driver module is that it has a power input for the driver itself, and then it has a little onboard 5-volt regulator that you can use directly to power your devices like this. So Arduino, I don't know if you can see it, little blue light is glowing. So we are good to go. Let's apply the power. I guess let's bring this back up. Make sure we still have. Yeah. All right. Let there be light. There we go. All right. That's about right. So not quite perfectly aligned there. Ooh. Let's do our let's tip this back up with our magic tilting stick. Oops. There we go. And invert. There we go. So yeah, so again, it's funny, like, right, you can tell whether it's aligned or not. It's like benching well, in a very real way, it's like benching a source 4, right? When the optics aren't aligned, you get these weird patterns. Make sure that optic is firmly in there. Yeah, there we go. All right, so that'll hopefully stay. So that's not the prettiest beam ever. In fact, I'm gonna reduce the exposure just one more click here. I want you to see what I'm seeing. Yeah. So yeah, it looks like a source 4 that needs to be benched. Yes. But interesting. Let's run it forward and back and see what happens. Let me get the brightness up here a little bit. It's funny, I think you can see the square shape of the emitter in this beam. Yeah, you totally can. Oops. And I've run off the end of my lead screw here again. So not terribly exciting. I guess I can take the power up some. That's sort of the point of this. But I mean, that's not a bad beam in and of itself. But I feel like everything that comes after that is just really uneven and janky. And, you know, to be fair, some of that could have to do with the fact that it's, you know, a $4.50 grandma lens. Ooh, that's fun. That's benched better. Let me turn the brightness down a little bit. But, like, that's not particularly usable. That would be usable if it was frosted. But it's not really getting any smaller. It's just sort of changing where the hotspot is. It's cool. It's just not really a thing. Well, just for the sake of thoroughness, let's try our old friend the 15-degree magnifier on there. Yeah, we'll try and get it pointed right down there. So yeah, it's not interesting. I mean, there's your spotlight. There's your hard edge beam. That's probably like the best I've seen it. So, well, there's your hard edge beam. I mean, if we discount that halo, what if it was a light that just zoomed from there to there? 1 or 2. 1 or 2. I mean, that's honestly, that's the cleanest beam I've seen from any light so far. I don't think, I mean, again, I don't understand the optics well enough to know, but like something is definitely in focus here. I wonder if I have a little tiny something that we could see, like if you've got a gobo-ish effect at any location in the beam path. If I stick a little piece of wire in here. Let's see if we figure out if it's in focus at any point that we had accessible. Because again, there's 2 lenses inside the magnifier optic here, and I sort of suspect the focal point is between them. Yeah, I don't think I can actually get at the focal plane of this thing. But, you know, so that's kind of interesting. Like, that's a really crisp, sharp beam there. You know, and we can overdrive this all the way to hell. Ooh, hello. Do you see it go blue? That was that same like color shift effect. I grabbed the coarse knob instead of the fine knob. So that's an amp and a half. That's fairly punchy. I think this is also just like a not quite as high a quality of LED product as are on the other ones that we've been working with. So it makes a little sense that the emission is not as good. Well, I mean, I guess take one more thing. Take the primary optic off here. Oh, and try not to melt the build tack. Oh my god. And try putting the granny lens right up to the emitter again. See what happens. Whoa. Well, that's cool. That's super cool. Let's automate that. Let's make that work. Let's get our old friend granny lens. Squish some more build tech onto it. Let's bring the platform as close as we can. Yes. And then squish this granny lens as close as we can. All right, so that's granny lens in place. Let's run it forward. I'm trying to put my arm somewhere that's not in the way. If I were to do this all again, I'd do it in reverse. But here we go. That's wow. That's cool. So one thing that's, apparent to me here, but might not be totally apparent there. So let me run this back in. So that is certainly like narrowing the beam down more cleanly than anything else we've seen tonight. Part of it, though, is the blow by of this lens is helping things, right? Because it's still acting like a point source. But then I just mean, let's see if I can just tilt. Will this see anything? It's a little far away. But you can sort of see here, well, here, we can do this better. Hello. We can point this where you can see the table, right? So this is the granny lens. Let me turn the current down here. That lens isn't glowing quite so much. This is all just stray light that's coming straight out of the emitter. Oops. Right, so you can see the beam too. So as I zoom in, you can see that beam getting narrower. Partly it's just because there's a lot more light that's just not hitting the lens. Like all of this space is still illuminated and just not used, which I think is contributing. Like, earlier these lenses were contributing toward the primary focal lens, but they were also distorting the optics in a way that was not super fun. Reconnection is successful. Ooh. This is... Let's see. Ooh. Thinking about it? Oh, no. It comes back up and then I have more dropped frames. I don't know quite what to do.